Okay, so today is on Law of Cosines, right? No do now. Why? Because no homework due today. Why? Because on Friday, which was 2 days ago, you were just doing work in class. So I'm lecturing all of 6.2 today, which is now Law of Cosines. And I will cover all of this material. And so this first part will be due Thursday. The second part is due Tuesday. Why? Because we have Friday and Monday off for 4-day weekend, correct? And so tomorrow, 6.1 part 2 is due. What is that from? That is from Monday, right? So that's due on Wednesday. And yes, I'm going to have it due now, even though it's a late start, because I'm not lecturing tomorrow, so I'll give you a short due now. And what was the second part? That was area, and that was word problems, right? And then I'm done. And so that means next Tuesday what you'll be doing is a pre-test, because Wednesday, yes, it's a late start, will be a test. I don't care it's a short day because it's a short unit. Questions? Okay, try to make it really clear. You need to take a picture before you leave so you don't have to think and remember. All right, so law of cosines. I'm just going to start out as if it was the same. Law of cosines is still the same direction. Solve the triangle. What am I given? Angle A is 120 degrees, B is 7, and C is 8. The directions tell me to round my lengths of sides to the nearest tenth and my angles to the nearest whole degree. And so I typically start out by drawing out my triangle. 120 goes here, 7 goes here, 8 goes here, which means I don't know A. What am I supposed to find? I'm supposed to find the measure of angle B, the measure of angle C, and side A. That's what I'm supposed to find. Once I've done that, I'm already done. So here is where I have to find a complete ratio, like angle A and side A, angle B, side B, angle C and side, so I can start doing my law of sines. Is there a complete ratio? No. In fact, no matter how I set it up, let's say I do it with A's to B's. Sine of 120 over A, sine of B over 7. How many unknowns are there? 2. Maybe I do sine of C over side 8, and sine of 120 over A. There's still 2 unknowns, an angle and a side, right? No matter how I use law of sines, I can't use law of sines because I'm always going to have 2 unknowns. That must mean I got to pull out something new called law of cosines. This is where I'm going to stop this problem. Can't do it right now. I'm going to do it in a moment. I need to go and prove to you law of cosines. In fact, I'm not even going to start out by giving it to you like I did with law of sines. I'm just going to go ahead and derive it, and then I will give you the rest. So it's going to come from an oblique triangle again, which means it doesn't have a right angle. But what I'm going to do, you can see the A, B, and C. What I'm going to do is I'm going to now put it in the coordinate plane. Put it in the coordinate plane. So at point A, that vertex, the ordered pair is 0, 0. This is angle C, and this is side C. Then that means that ordered pair is called C0. Well, I don't know that ordered pair using A, B's, and C's or A, B's, and C's at all. I have to just say X, Y. Because that one is 0, 0. That one has one of these letters, C, and then a 0. This one I cannot. And obviously I don't know the angles at all either. I have no idea. It could be any kind of oblique triangle. So from all of that, I'm going to develop a formula that I can use. So what I would like to do, first off, is I would like to substitute x, y with the little a, b, and c, or the capital A, B, and C, kind of like our area formula on Monday, yesterday. I wanted it rewritten with only those pieces from an oblique triangle. So let's go ahead and let's try to substitute. Let's see what I could do. Why don't I do And I already added in here a height. I just went through the middle, added a height in there, right? And so how about cosine of angle A, whatever it might be? Cosine would be what? Well, let's see. If this is x and this is 0, 0, isn't the way you get here is this is from here to here an x length, and from here to here, isn't this a y length? Right, that's how you plot a point. So cosine of A would be adjacent over hypotenuse. I would like to substitute my x and y. So I'm looking for relationships that have an x and y, and the other things are my little a, b, and c, or my capital A, B, and C. So I'm successful so far. I'd like to get something for my y. Well, if I stay here and I just do sine of angle A, that is opposite over hypotenuse. There's my x and y. I'm going to isolate my x and y and resubstitute that in. Now I have the name for that ordered pair based on the little a, b's, and c's of the capital A, b's, and c's. Again, stuff from my oblique triangle. I'll have to go find anything additional like a height. So now I'm going to take that information and I'm going to go find the length of side A. I'm going to scoot that phrase up here. In other words, what's the length of that segment on a coordinate plane? The coordinate plane, I want to know the length of that line. How do I do that? What formulas did they teach me back? Probably in middle school, and then in Algebra 1, and then in geometry. I don't think we use it in Algebra 2. I would not let us use it in Algebra 2 because I can't stand this formula. But how do I find the length of any segment in the coordinate plane? Because I have a coordinate at either, that's that coordinate and that coordinate. How do I find the length of that segment? Slope doesn't give me the length of a segment. It gives me how much it's tilted. Distance formula. Distance formula. Let's see if I can remember it generically. Oh, I remember this. This is called Pythagorean Theorem. Right? Pythagorean Theorem, right? Side length squared plus side length squared, right? Doesn't it kind of look like that? And then square root, but what does A mean? It means the length of a side. What does B mean? Length of a side. Well, I don't know the length of this side, so can't I just say the distance between x2 minus x1 and, right? So I'm really just doing, I have no eraser. So I don't want to find side D, I want to find side A. Wow. And let's see, which point do I want to call what? Let's call this one point 1. This one up here, we'll call it point 2. So I want my x2. Here's x2, y2, right? Belongs up here. B cosine of A minus x1, c squared. What's my y2? B sine of A minus what's my y1? And this is my point 1, 0 quantity squared. Again, all I'm doing is deriving the formula for you to prove to you when I gave you the law of cosines, I didn't pull it out of the air. Did I do lots of torturous math? Let's see. Let me just continue to clean this up. What does that mean? Let you just stop and figure out what the heck I just did there. Just basic math. Just got letters and signs. I'll let you catch up writing and in your mind. So I couldn't do this yet. You notice everything has got A's, B's, and C's in it, right? The first thing I had to do is substitute that point for A, B's, and C's. This allowed me to make the rest of this possible, to have all the side lengths or angle measurements for my oblique triangle. So I'm going to continue. So my law of cosines is right here. I'm just simplifying it, and it will be right here. Okay, so let's see here. What do I do here? Right? Oh, I know what I did wrong. Sorry. That's why I was having a brain fart. The middles don't cancel. This is not a difference of squares. This is two cubes. This is a cube. Sorry. I knew I was missing one piece. Right here. B squared cosine squared A. And two of these, negative 2 CB cosine A plus C squared plus B squared sine squared A. I didn't do the two middle terms and add them up, that there was two of these what? CB cosine A. Oops. Hey, they're blowing away. Again, I'm going to play with this guy here and this guy here, extract out a B squared because I want to simplify this. I already know what that's going to be. What is that going to be right here in my parentheses? 1, isn't it? Okay. So I have that and that. I just have this piece left. Minus 2CB cosine of A. That is 1. Oh, that's sweet. That shortens this whole thing up. B squared minus 2CB cosine of A. I'm going to go back and square both sides so I can get rid of my square root. Just get rid of my square root. I'm going to write that in alphabetical order. Ugh, forgot C squared. Lord, help me. Hi, Chihuahua. It's me, just battling. Too many A, B's, and C's. There he is. Had to put him back in here. He went to 1. B squared plus C squared minus 2bc cosine A. He's not squared. Here are the other two. Once I know this one, I have one memorized, I can do the other two without memorizing. I only have to memorize this one. Just like I only memorize sine squared x plus cosine squared x equals 1 to get the other ones with cotangent and tangent. I just divide by sine squared of x or divide by cosine squared of x. How did I memorize that? If this is a squared, I need 1 for b squared and 1 for c squared. The a was here. There's no other a's except for here. So if this is an a squared, it's capital A. B squared, capital B. C squared, capital C. Then the other two sides added, subtract 2 of those same sides, right? Minus 2 of those same sides. And we're in law of cosine, so it's all cosine, not sines. Once you memorize one, you can do the other two. Know the pattern. Isn't that Pythagorean theorem? Right? Darn near, right? Inside of an oblique triangle, there is some kind of a right triangle that we just add a little bit more, subtract a little bit more. Right? That's all it is. It's still Pythagorean theorem, it's just not quite a right triangle. So it looks very similar to find that side line. There's just some other stuff attached to it. Well, I'm going to put those above. I have this. I have this angle A right there. And I have side B and side C. Side B and side C. I could find him first, couldn't I? So in each of these, this is the included angle. In angle A, I know B and C. In included angle B, I know A and C. In included angle C, A and B. If I have that, I can't use law of sines, but I can use law of cosines. So let's go use law of cosines. A squared equals B squared plus C squared minus 2BC cosine capital A. So A equals the square root of, what's B? 49. C, 64 minus 2 times 7 times 8 cosine of 120 degrees. Go get my handy dandy little calculator to spit that out. Yeah, I think I'm going to do a little bit more hand math first. What's that, 56? What's 2 56s? 112. And what is that? 3, 10, 11. Radians or degrees? See if you get 13. Yes? Okay. It's an, what is it? It's an exact answer, right? Right? Yes. So it's exact answer. So I was down here thinking it was going to be this, and it ended up being exact. So that means for me, I'm going to put it back over here. Oh, I still got to find B and C. What should I do? Law of sines. Oh, God, I don't want to do law of cosines anymore. Oh, I like law of sines. Okay, let's do law of sines. Okay, I'm just doing this so I have to go up and down so I can see this. I will do my work down here. Let's see, I have a complete A. Sine of 120 degrees over 13, and, oh, I don't know. Let's do sine of B over 7. So let's see, sine of B equals 7, sine of 120 over 13, right? And then sine inverse of 7 sine of 120 degrees over 13 equals B, and find out what that is. So I need my degree to the wholest, oh, yeah, to the degree. 120 sine times 7 divided by 13 inverse sine. So that would be to the whole number, wouldn't it be 28 degrees? Is that what you got? 28 degrees. It is approximate, so I'll find out my approximate C. What is that? 120 and 28, that's 148. I want a 32, and I'm done. Why am I... Why am I not going to look for a second triangle? This one here is already beyond 90. There's no way to make a second one, right? There's only one way of doing this. Okay. Because the second one would be in quadrant 2, which is between 90 and 180. I can't have two of those be oblique. I would never make a triangle. So yes, I still looked, but I knew not to even bother mathematically trying because of that number being so big. This is a totally new kind of given. What's new about this? No angles at all. Just 3 straws cut in those lengths. Put them together and tell me what the angles are. Is it going to make 2 triangles ever? No, that was side lengths locked. Here's a straw, here's a straw, here's a straw. Make a triangle. One way, right? Nothing more. Okay. So now we get that out of our head. I don't have to worry about that. Again, I don't try to draw to scale, ever. Only in geometry I try to do that when you're first learning. Obviously, law of sines will not work, correct? I have to use law of cosines. Let me do my find box. All right. Oh, interesting. My law of cosines starts out by going like a squared equals or b squared equals or c squared equals, except I already know the sides, don't I? In this oblique triangle, in fact, I even drew one. Can't I have an obtuse side? Obtuse angle, sorry, didn't mean side. Yes. Obtuse angle, couldn't I? Where would it be? Let's solve for b first. Once I get that out of the way, then the other two are guaranteed acute. Because I might have to use the inverse of law of sines. I don't have to bother looking for a second. 2 reasons why. So let's go ahead and get that obtuse one out of the way, B. So I guess that means I'm going to use this one, because this was the one that has angle B. Let's see, what was that? Looks like Pythagorean Theorem. Then I minus 2 of those same with cosine of B. But I don't know that guy. Means I got to isolate him. Wonderful. Sure. I'll do that. We just use algebra. Subtract, subtract, divide. Subtract, subtract, divide. I like doing it with my A, B's, and C's instead of putting any numbers in right now. And I'm going to do it all generically. Now I'm going to put in numbers. Interesting. This is negative. Cosine is negative in quadrant 2, isn't it? Because my inverse of cosine, I can go from 0 to pi, all of my answers, or 0 to 180 degrees. So he's going to be an oblique. He's going to be beyond 90 degrees because it's negative. My ratio is negative. Interesting. So I did have an oblique here. An acute triangle. 11 divided by 80 negative inverse cosine, hey, divided by 80 negative equals, how would I try that? Inverse cosine. Yes? It's in quadrant 2. That makes sense. The cosine of 98 degrees should give me something negative. I like that. So that was B. How would you like me to find A and C? Do you want me to use law of cosines? No. I have B's, right? Sine of, oops, oh my Lord. 98 degrees over side B is 10. I don't know, it doesn't matter. They're all acute. Who cares? How about sine of A over 8? So sine of A equals 8 times sine of 98 degrees over 10. Sine inverse of sine of 8 sine of 98 degrees over 10 equals A. So what is that? $52? Mm-hmm. So it looks like when they give me 3 sides, I have to do this. And then I could abort it and go to sine. But when they gave me an included angle, I couldn't use law of sines either, but I could directly use law of cosines and find the third side. Directly. Just plug it into the formula and spit it out. and then use law of sines again. So these are the two situations where you'd have to use law of cosines. Heron''s Heron's formula. It's the area of a triangle given only the sides, lowercase a, b, and c. How do you find that area? In yesterday's, in law of sines, we actually had a trig function in there. We actually had an angle measurement. We had two sides with an included angle. We developed a formula to find that area. Well, what if I'm only given 3 sides? Those are S's. When I'm doing algebra, I don't just make an S like this, looks like a 5. I try to do this to it. It's an S, that's an S, that's an S, that's an S. That's the A, B, and C. Where S, that S is 1/2 P, and that P stands for perimeter. I am not deriving this formula. I'm just giving you the area formula. Just given it. We're going to practice using it once, and that's it. So it might be something where you know that one side is 12 yards, B is 16 yards, and another side is 24 yards, and it makes a triangle. And you're asked to find the area of it. This is where you're going to use the Heron's formula. It's the most straightforward. I don't have to get any heights. I have to check and see if there's a right angle. I just plug it in and spit it out. Well, first I'm going to go get what my S is. My S is 1/2 perimeter. Perimeter is adding up all the sides. What is that? 2, 3, 4, 5, 52? 2, 3, 4, 5, 52. So half of 52 is 26, so my S is 26. So what is that going to be? 26, and then 26 minus each of the sides. 26 minus 12, 26 minus 16, and 26 minus 24. It's 26, which is what? 14, 10, and a 2. And what is that? That's 20. That's 280 and 26, whatever my calculator says, and then approximate it, whatever it is. Just a calculator. And I'll get it. You can get it. 26 times 14 times 20 square root. You get approximately, I don't know what they want me to round it to, 85.3 to the nearest tenth, right? Try it again. 26 times 14 times 10 times 2 equals square root. Yes, that's what I got twice. Yards squared, because it's area. So much carpet, paint, grass. Like I said, I'm doing all of law of cosines today. Last thing. Well, I'm not teaching for the rest. I can't say that. We'll do some activities over the next 2 days. So the next 2 days, I'm going to give you time to work in class, but I'm also going to have you do some enriching activities. And those are the problems I've been skipping in 6.1 and 6.2. One's right in the middle. I've been skipping. I want to do those together in class. Because if I assign them, you'll just skip them. You won't do them. So I'm going to make you do them in class. Okay, 2 airplanes. So what is this? This is the practice problem in the book, but I'm doing the red one. So I'm not doing the one that's worked out. So there's one in the book just like this, worked out. Okay? I'm doing the checkpoint, whatever it is, number 3, number 4. 2 airplanes leave an airport at the exact same time. but on different runways. One flies north at 400 miles per hour. So we'll have him go north on the runway, and he's traveling at 400 miles per hour. The other plane flies on a bearing north 75 degrees east at 350 miles per hour. So down pretty low. Oops, not degrees. So I didn't say that these two both left at the same time. This guy here, at the same exact place, right? The same airport maybe, I guess. It just says airport. Let's say airports. And maybe he's traveling over here. I don't know. And I just moved that vector over here. So we'll be doing some of this vector work in 6.5 and 6.6 is vectors. We'll be drawing pictures with vectors. So for those in physics class, you'll understand that. Okay, I've sketched out to here. I don't know what to do with that. I better put 75 degrees in here. How far, that makes me think distance. No bearing. My answer is already going to be a distance, 3 feet, 4 feet, whatever. Apart will the airplanes be after 2 hours? Oh, so if one's going this direction, one's going this direction, so they want me to find is that length there, right? So I'm going to call that A, B, C. You want me to find side A. Find little a. That's all you want me to do out of this problem. You did say I'm traveling for 2 hours. Because right now I only have 1 degrees. I don't have lengths. But this guy here is traveling 400 miles per 1 hour, and he traveled for 2 hours. So what is the length? How far away is he from the beginning? 800. And this guy traveled 350 miles per hour, and he's traveled for 2 hours. So what's the length of him? Oh, I got it. So I have an included angle with 2 sides. I cannot use law of sines to find that. I have to use law of cosines. So since they want me to find A, that's the one I'm going to use. B squared plus C squared minus 2BC cosine capital A. I might as well go ahead and get myself all ready. Just plug in all the numbers. So one of them is 800. One of them is 700. Plug, chug, spit out, get an answer, right? That's all you have to do. It's actually shorter than doing all the other problems. It's this word problem. You just have to understand it. Okay, I got the same answer twice. I'm done. Area. Oh, these are just word problems. This is solve the triangle and area. The area is just a formula. That's easy. This one, law of cosines, going to run into 2 situations. All sides or two sides with an included angle. I have to use law of cosines first and law of sines to finish. These are just word problems. I was recording. My computer shut off. Wonderful. Oh, it's still recording.